Okay, this video is dealing with speed and velocity and the difference between the two. So we know we're driving down the road, we're going 70 miles per hour, we kind of have a feel for how fast that is. So a couple things. Speed is a scalar quantity, which means that it is quantity that describes the magnitude only. And when I say magnitude, in this case, I mean how fast. The number, I'm going 70 miles per hour. That's how fast. That's the speed. Okay, scalar quantity, magnitude only. Definition here. If an object takes a time interval to travel a distance, then the average speed of the object is given by average speed is distance traveled divided by the time of travel. Sometimes you'll see this speed, a little s with a line over it. The line means average. And this is dependent upon the distance traveled and the time that it takes to travel that distance. Now, when we talk about distance, remember that is the total length of travel, and that can be different than the displacement. The SI units for speed are meters per second. However, it is appropriate to express the speed in centimeters per second if you're talking about something that's moving really slowly, like a ladybug or some kind of insect, or even kilometers per hour. If you're talking about an airplane or a car, it is okay to express those units in kilometers per hour. So, speed. How is that different than velocity? Okay, so with velocity, this is a vector quantity, which we know that vectors describe both magnitude and direction. Okay, again, remember magnitude is like the number, how fast. The average velocity is the displacement divided by the amount of time that it took to undergo that displacement. And the big difference here is that the average speed relates to distance, whereas the average velocity relates to displacement. And we know displacement is the net length versus the total length of travel. Okay. And remember, there's a couple ways to determine displacement. Displacement is the final position minus the initial position, or displacement is like this vector sum of all the individual displacements, something that looks kind of like this, okay? So there's kind of two ways to determine displacement. But the big thing with average velocity, okay, and again, this line just means average, it is the displacement divided by the time. Sometimes it's also referred to as the rate at which the position changes. When I say rate, think of time, and when I say position change, that is another way to define displacement. Okay? And then there's the equation for average velocity, and this is actually how it's written on the yellow sheet. And again, the units, the SI units would be meters per second, but you can also express this in centimeters per second or kilometers per hour. Now, another big thing here with average velocity, you're not going to only include the magnitude, but you have to remember to include the direction. So it gives us a little bit more information than just how fast. It tells us direction as well. So let's look at a couple problems. So let's see. A bus travels 280 kilometers south along a straight path with an average velocity of 88 kilometers per hour to the south. The bus stops for 24 minutes. Then it travels 210 kilometers south with an average velocity of 75 kilometers per hour to the south. How long does the total trip last, and then what is the average velocity for the total trip, okay? Now, I'm going to draw a picture. I think pictures are very helpful. I'm going to kind of define here my direction. So I'm going to say that south is downward towards the bottom of the page and that that's negative. So we're going to have a bus. There's our bus. And it's going to be traveling. It's hard to see. It's going to be traveling south. So it's going to start, initial position would be 0. Initial time would be 0. It's going to travel 280 kilometers south. I'm going to say that that is the first displacement. And I'm going to represent that with a negative just so I know that it's south, negative. It's going to stop here for 24 minutes. And at this position here, it's at the 280 kilometer mark. And then it's going to continue for a second displacement. And that would be negative 210 kilometers. Again, the negative representing south. And we can say that its final position here is the negative 490 kilometer mark. Now it also gave us velocities. So here the velocity, the average velocity for the first leg of the trip would be negative 88 kilometers per hour, whereas the velocity, average velocity for the second leg of the trip is going to be negative 75 kilometers per hour. Okay, so I'm going to look at what I have, look what I'm looking for. So I'm looking for how long, which refers to a time. Okay, so I'm dealing with average velocity. I know the average velocity. I know the displacement for each leg of the trip. Looking for time. So I need to find like the time for this section. I know the time that I stopped was 24 minutes, and I need to know the time for the second section. So I'm going to use the equation. Average velocity is displacement divided by the time. I'm going to go ahead and rearrange the equation for time. So that's going to be displacement divided by average velocity. So for this first part right here, for this first part, I'm going to take the displacement, that's for the first leg, negative 280 kilometers divided by negative 88 kilometers per hour. And for that first section, and notice the negatives cancel because you can't have a negative time. And this is, my bad, this is not velocity. This is the time for the first section. And so this would be 3.18 repeating. So let's just do 2 sig figs here, 2 sig figs. So 3.2 hours. Okay. Now I know that the time I stopped for is 24 minutes, but here's the problem. Notice the time for the first section is 3.2 hours, and I need to convert this 24 minutes so that I have it in terms of hours. So I'm going to get rid of the minutes, go to hours, and there's 60 minutes in 1 hour, and that's going to be 0.40 hours. And then I need to know the time for the second section, which is going to be the displacement of the second section, which is negative 210 kilometers, divided by negative 75 kilometers per hour. And that gives me 2.8 hours. Now I want to explain the units here. How does taking kilometers and dividing it by kilometers per hour give me hours? So if I take kilometers and I divide by kilometers per hour, if I flip and multiply, notice the kilometers cancel out and I'm left with hours. So I'm looking for the total time. So I'm going to take my 3.2 hours, add my 0.40 hours, and add my 2.8 hours, and I get let's see, 6.4 hours. Notice here, there's not a sig fig here, not a sig fig here, so there's not a sig fig here. So 6.4 hours is the total time. All right, now it wants to know the average velocity, which is the total displacement divided by the total time, which in this case, we know the total displacement is the final position minus the initial position divided by the total time. So that's going to be negative 490 kilometers minus 0 divided by 6.4 hours. And I want to say, let's see, 77.56, but only 2 sig figs, 77 and negative kilometers per hour, or you can do 77 kilometers per hour to the south, but you have to include direction because it's asking for the average velocity, which is a vector quantity. Okay, one more way you could do this is the total displacement is the individual displacements added together, vector addition, and so that would be negative 290 kilometers plus negative 210 kilometers.